Welcome to lesson 2 of this course. In this lesson, we'll talk about the way machines learn. In any machine learning problem, we need to have data. And to use the data that we get provided with, we need to be able to import the data and manipulate it. First, we import the data. We then make the necessary changes if we need to, like deleting unnecessary data. We can sometimes need to apply data augmentation, which we'll talk about later in this course. We then split the data into 2 or 3 parts named the training set, the validation set, and the test set. Sometimes there are only 2 sets, one for training and one for evaluation. Know that the names validation set and test set can be used interchangeably, though both can exist in the same problem we're trying to solve. The training set is the data that we fit our model to, or train our model on. The model is like a function that takes an input and predicts the output. We train the model so that it can make good predictions. The validation set is used during training and is used to tune the hyperparameters of our model, which we define by hand. It can also help us know if our model is overfitting, which we'll talk about soon. The test set, however, is used to compare different models and choose which one is the best. After working with our data, we then need to define the model. Our model is what makes predictions from the given input. In deep learning, there are many architectures that are known to perform well in certain problems, so we can use those defined architectures, or we can create our own architecture if we have the necessary knowledge. After creating the model, we need to start training. Here we changed the parameters of the model. How a machine learning model learns is that it changes the parameters that it uses to make these predictions. For example, here we have a linear regression problem. Our line is steeper than it should be, so we need to change the slope parameter. In y equals mx plus c, we need to change the m. So if we try to improve the model's predictions, we should decrease the slope. In the other image we have here, we have the loss function versus the weight. We'll talk about loss functions later in this course. The weight's value has a positive gradient at this point. We would like to decrease the loss, so we would go the other direction. If the gradient was negative, we would increase the weight's value. Our goal is to reach the lowest loss we could. An epoch is a term that is used to refer to one pass through the training data. We can take each data point and learn data point by data point, or we can learn by batches. There are many different approaches that we can take that we'll talk about later in this course. During one epoch, we change the values of the parameters to the best, hopefully. The learning rate is how big the step that we use to change the parameters. If the learning rate is too big, then we might not reach the lowest loss as we keep passing it. And if the learning rate is too small, then it will take a lot of time to reach the minimum loss. So the learning rate is something that we experiment with. Sometimes there are problems when training a model. One common problem that you may already know about is overfitting and underfitting. Underfitting is when a model doesn't model the training data and in turn the test data. Overfitting, however, is when the model learns unuseful information provided to it in the data, like anomalies. When it learns information that is only present in the training data, it performs badly during testing. We need a model that is general enough to perform well on the test set and after training on the training set for just the right amount of epochs. So that's it for this lesson. We talked about some core concepts in machine learning. Soon, we'll use these concepts to make our own projects. See you next lesson.